Hello everyone. Today we are going to solve a very interesting question based on the concept of orthogonality of curves from the chapter of application of derivatives. First of all, let us read the question. The condition for which the given curves are orthogonal. The curves are y square equal to x and xy equal to k. Okay. Now before solving the question, I might interest you in understanding the angle between the two curves. So let's start. First of all, you have been given two curves, curve C1 and curve C2. If they are not intersecting or touching each other, then you cannot calculate the angle between the two curves. Okay, so you can see over here I have seen two curves which are not at all intersecting or touching. You cannot calculate the angle between the two curves. Then the second is, suppose if the two curves are touching each other, okay, something like this, then you can calculate the point of intersection definitely. But at the point of intersection, how many tangents you can draw? As you have guessed it correctly, you can draw tangent like this, right? There's only one tangent you can draw when the two curves intersect each other. So the angle between the tangent will be 0 itself over here. So theta will be equal to 0 because the curves were intersecting each other. Okay. Now if you have two curves which are intersecting each other, something like this, curve C1 and curve C2. Okay, and this is your particular point of intersection x1 y1. Then at the point of intersection you can draw two particular tangents. One tangent for the curve C1, which I might draw like this. Have a look at this tangent T1 at the point x1 y1 on the curve C1. Then I can draw one more tangent at the point x1 y1 on the curve C2, something like this, right? So this will be your tangent T2. Now, in order to calculate the angle between the curves, all you need to do is find out the slope of the tangents and find out the angle between the tangents. The angle between the tangents is actually the angle between the curves. Okay, as the curves were intersecting each other, there were two different tangents, hence there is an angle between the two tangents. Whereas in the earlier case, the curves were touching each other, hence at the point of intersection you can draw only one tangent. One tangent yani the theta will be 0 because there are no two different tangents. But when the curves are intersecting each other, something like this, you are able to draw two tangents, hence you will be able to get an angle between the two tangents. Now from the chapter of straight lines we know that the tan theta is given as m1 minus m2 upon 1 plus m1 m2. Okay, where m1 is the slope of first tangent, m2 is the slope of second tangent. Now let me interest you in understanding this, that m1 is the slope of the tangent t1 calculated at the point x1 y1 for the curve c1. Okay, and m2 is the slope of the tangent t2 calculated at the point x1 y1 for the curve c2. Okay, now for the orthogonality of the curves, what do you need to understand? Orthogonality. The orthogonality of curves means that the tangents drawn at the point of intersection of the curves intersect each other at 90 degree. So theta has to be 90 degree. So tan of 90 degree has to be equal to m1 minus m2 upon 1 plus m1 m2. But tan 90 is nothing but infinity, so infinity has to be equal to m1 minus m2 upon 1 plus m1 m2. Now whenever the answer is infinity, your denominator has to be 0. Therefore 1 plus m1 m2 has to be equal to 0, and that implies m1 m2 has to be equal to minus 1. This is the condition of orthogonality of two curves, that you calculate the point of intersection x1 y1, you calculate the particular slopes at x1 y1, m1 and m2, their product has to be minus 1. So this is the condition for orthogonality of two curves. Okay, now coming back to the point of the question, you have been given two curves y square equal to x and xy equal to k. So let me write down y square equal to x and xy equal to k. So let us say x1 y1 is the point of intersection. So this be the point of intersection. Okay. Now as x1 y1 is a point of intersection, I can very easily say that y1 square equal to x1 and x1 y1 equal to k, because x1 y1 will lie on both the curves and hence it will satisfy both the curves. Pretty simple, right? Okay. Now let us try to calculate the slope for the particular curve. So differentiating both sides with respect to x, d by dx of y square, d by dx of x, it would be equal to implicit derivatives y square, or chain rule you can say. Y square will be 2y dy by dx and derivative of x will be 1. So dy by dx comes out to be 1 by 2y. But this is a general slope, right, at any particular point on the curve. But I want it specifically at the point of intersection. So that will be dy by dx at the point of intersection x1 y1, which would be equal to 1 by 2y1. Right, so that way my m1 comes out to be 1 by 2 y1. Very simple, right? The second curve was xy equals k. Now differentiate both sides with respect to x. So differentiation of xy equal to derivative of k. K is a particular constant, so derivative would be 0. Over here I will apply UV rule. So product rule, x derivative of y plus y derivative of x equals derivative of k 0. This would be equal to x dy by dx plus y equals 0. That ways. Okay. Now your dy by dx comes out to be minus y by x, but this is a general slope. What I need is at the point x1 y1, which was the point of intersection, to be precise, x1 comma y1 comes out to be minus y1 by x1. So m2 comes out to be minus y1 divided by x1. m2 is the slope of the tangent at the point x1 y1 with respect to the curve c2, which is xy equal to k. Very good. Now these two slopes should product minus 1 for the orthogonality as given in the question. m1 was equal to, let me see, 1 by 2 y1. So let me write down 1 by 2 y1. m2 is equal to minus y1 by x1 minus y1 by x1 equals minus 1. y1 got cancelled, minus minus got cancelled. You got 1 by 2x1 equal to 1. Therefore x1 equal to half. Okay, we got the value of x1 as half. But we also had one more thing, that x1 y1 satisfies the two curves, and we had y1 square equal to x1. You can go back and check. See this, y1 square equals x1. So you get the value of y1 square. So y1 square would be equal to x1 as half. Now you can calculate the value of y1 over here, but I won't be calculating. The reason is all the options are in terms of k square, as you can see. See, all the options are in terms of k square. That means we have to deal with the second curve. Now the second curve satisfaction would be x1 y1 equal to k, right? Let us square both sides. Once I square both sides, I will get x1 square y1 square equal to k square, k being a constant. x1 was half, so half square. y1 square, as we got, you can check over here, y1 square was also half because y1 square equal to x1. So this comes out to be half only, equals k square. So this will be 1 by 4 into 1 by 2 equals k square. So all you get is 1 by 8 equals k square, and that way you get 8k square equals 1. Okay, so this way you get the answer as 8k square equal to 1. You can check the answer, option B matches with it. Okay, so the whole point of taking this question was making you understand the angle between two curves. When the two curves do not intersect or touch each other, there is no angle between the two curves. When the two curves touch each other, there is only one tangent, so angle would be 0. When the two curves touch each other, intersect each other, the formula for angle from the chapter of straight lines is tan theta equal to m1 minus m2 upon 1 plus m1 m2. And when the angle is 90 degree, you have product of slopes equal to minus 1. Using that only, I got the value of k square as 1 by 8 and ultimately 8k square equal to 1. So I hope you like this video. If you like this video, keep studying. This is your friend Amol More saying bye bye to you for now.